Welcome to Everything in 5 Minutes, the show where we explain complex topics in under 5 minutes. Today, we're diving into one of the most fascinating areas in modern technology: neural systems in machine learning. If you've ever wondered how machines learn to recognize faces, drive cars, or even recommend the next movie to watch, then stay tuned, because neural networks are the backbone of these innovations. What are neural networks? A neural network in machine learning is inspired by the human brain. Just like the neurons in your brain that fire off electrical signals when you recognize a face or read a book, a neural network in machine learning is made up of artificial neurons that process information. At its core, a neural network is a set of algorithms designed to recognize patterns. It takes input data, processes it through multiple layers, and outputs a result. These layers are the key. Each one helps the network understand more complex features about the input data. Let's break it down. Input layer. This is the first layer of a neural network, where raw data like images, sounds, or text comes in. Think of it as the senses of the system. Hidden layers. These layers, which are sandwiched between the input and output, do the heavy lifting. Each layer breaks down the input information into more refined bits. The more hidden layers you have, the more complex patterns the system can understand. For example, if you're training a network to recognize a cat in a photo, early layers might recognize simple shapes, while deeper layers understand full structures like the cat's face. Output layer. This final layer produces the result. It could be anything from recognizing a cat in a picture to predicting the stock market. How neural networks learn. Now that we know the structure, how do neural networks actually learn? Neural networks learn through a process called training. During training, they're fed tons of data and adjust themselves to make better predictions or decisions over time. The goal is to minimize error through a technique called backpropagation. But how does that work? Let's say you're training a neural network to recognize handwritten digits. You give it a digit, and it predicts what number it is. If it's wrong, the network compares its prediction with the correct answer, and the error is calculated. Using backpropagation, the network goes back and tweaks the weights, or the importance of different connections to improve future predictions. It's like learning to throw a basketball. The more you practice, the better your brain adjusts your hand movements for a perfect shot. Similarly, the network fine-tunes itself based on its mistakes, continuously improving. Deep learning in neural networks. Neural networks with many hidden layers are often referred to as deep neural networks, and this is what drives deep learning. Deep learning has revolutionized industries from healthcare to entertainment. For example, in healthcare, deep learning helps detect diseases from medical images like X-rays and MRIs. In entertainment, platforms like Netflix use it to recommend shows based on your viewing history. Why do deeper networks work so well? Because the more layers a network has, the better it becomes at understanding complex data. This allows neural networks to handle tasks that traditional machine learning algorithms struggle with, such as recognizing speech, driving cars, or even playing video games better than humans. Real-world applications. Neural networks are already a part of your daily life. Some popular applications include self-driving cars. These networks process sensor data to understand the road, avoid obstacles, and make driving decisions in real time. Speech recognition. Virtual assistants like Siri or Google Assistant use neural networks to understand and respond to your voice commands. Healthcare. Neural networks analyze medical data, helping doctors diagnose conditions more accurately and even predict patient outcomes. Natural language processing. NLP. This is used in chatbots and translation services like Google Translate, helping machines understand and generate human language. Challenges in the future. Neural networks are powerful, but they have their challenges. They require massive amounts of data and computing power to train, which can be expensive and time-consuming. Additionally, they can sometimes make decisions that are difficult to interpret, leading to concerns about transparency and fairness, especially in critical areas like law or healthcare. Looking forward, advancements in neural networks will continue to transform industries. We're seeing progress in creating more efficient models, reducing the need for vast amounts of data, and improving the interpretability of decisions. It's an exciting frontier for artificial intelligence. Wrapping up. In summary, neural networks in machine learning mimic the human brain's ability to learn from data. By training on large datasets, they become better at recognizing patterns, making predictions, and solving complex problems. Whether it's recommending a movie or diagnosing a disease, neural networks are already shaping the future. Thanks for tuning in to Everything in 5 Minutes. If you enjoyed this episode, don't forget to subscribe for more bite-sized deep dives into today's most fascinating topics.